Okay, so question 7. What is the standard enthalpy of formation of this isomer C8H18 for a particular isomer? The following reaction produces 5,113.3 kilojoules of heat per molecule or per mole of, I guess this is octane, consumed under standard conditions. And then they give us the balanced equation, so I'm going to write down the same thing. Octane gas plus 25/2 oxygens makes 8 carbon dioxides plus 9 H2O gas. Okay, so they also give us the delta H of the overall reaction, which is negative 5,113.3 kilojoules. Okay, so to answer this question, I'll first write down the expression for the delta H of reaction. So this is equal to the sum of N times the delta H of formation of all of our products minus the sum of N times delta H of formation of all of our reactants. Okay, so I can also show what this looks like for our example. So N, that means number of moles, so that's why it's important for your reaction to be balanced, because it has an effect on the overall delta H of the reaction. So starting with our products, we have 8 carbon dioxides. So it's going to be 8 times the delta H of formation for CO2 gas. So it's also important to know what phase your compound is in as well, since depending on whether or not it's a gas or a liquid, then that will also affect the delta H value. So I'm just also going to write the state that all of the compounds are in. And this is going to be added to 9 times the delta H of formation of water. So water as a gas. So those are both of our products. And now I'm going to subtract our reactants. So our reactants is 1 mole of the octane, so I don't need to write any coefficient in front of it. And this is what we are trying to solve for. C8H18 gas. And then this is added to 25/2 delta H of formation for oxygen. Okay, so when we have an element that's in its elemental state, such as oxygen, its delta H of formation value is 0. So I'm just going to cross out this whole part. And now I just need to look up the values for all of the delta H of formations for carbon dioxide and for water. So let me just look it up. So these values are usually given in the question, or they tell you to look at the table for standard enthalpies. So this can be in your textbook or at like the back of a book. So first we're looking for carbon dioxide gas. So its delta H of formation is negative 393.5 kilojoules per mole. I'm just going to write that down. And I'm also just going to show that this should be 8 moles times negative 393.5 kilojoules per mole. Okay, so this is added to 9 times the delta H of formation of H2O gas. So on the table, this is equal to negative 241.8 kilojoules per mole. Okay, so that whole thing minus what we are looking for, which is the delta H of formation of C8H18 gas. Okay, so I can also plug into this equation what was given in the question for the delta H of reaction, which was negative 5,113.3 kilojoules. Okay, so if I simplify this equation and bring our unknown to the other side to make it positive, and then bring the negative 5,000 over to the other side, you get positive 5,113.3 kilojoules minus this whole bracket here. So if you do the math, our moles will cancel out and we get 5,324.2 kilojoules. So now let's just subtract the two and you end up with negative 210.9 kilojoules. Okay, so let's see what the junior tutor said. The heat of reaction, also known as the enthalpy of reaction, is the change in the enthalpy of a chemical reaction that occurs at constant pressure. It is a thermodynamic unit of measurement useful for calculating the amount of energy per mole either released or produced in a reaction. It can be calculated using the formula delta H of the reaction equal to the sum of N times the delta H of formation of products minus the sum of the N times the delta H of the reactants. Standard enthalpy formation of CO2, H2O, and oxygen can be determined using the table for standard enthalpies of different compounds. In addition, since oxygen is in its elemental form, which is the gas, its standard enthalpy is always 0. So it is applicable to all elements that are in its elemental form. So the formula above should look like this. So they have 8 times the delta H of formation of carbon dioxide plus 9 times the delta H of formation of H2O minus what we're looking for, which was the delta H of formation of the octane plus 0. Okay, so then they plugged in all their standard enthalpy values and ended up getting negative 210.9 kilojoules. Yep, so this solution is correct.